Dear Sapdolf, can you tell me about ICM today?
Sure, what do you want to know?
As always, everything.
Okay, we will go through it step by step, from architecture to practice.
Great. Let's start.
Let's start with the purpose and history. In the early 2000s, we had the dot-com era. The internet exploded at that time, and consequently serious business systems had to be able to access the internet, or at least to the open protocols commonly used on the internet. In 2001, SAP AG released Web Application Server version 6.10, and it included a brand new component of the basis module, ICM, Internet Communication Manager. It was used to communicate via HTTP with the outside world, both for connections where SAP is the server and the client. Over the years, admittedly, the supported protocols have arrived, but the ICM architecture has not changed. However, we will return to this later. For now, you need to remember that ICM is a component that connects the SAP system to the outside world using the so-called Internet protocols. It's worth knowing that the word Internet is no longer entirely accurate here, since these protocols have also come into common use for internal communication between various business systems.
I understand. Where can I find this component?
You probably remember my A4H system, right?
Yes, it's the free ABAP platform trial that you installed on a mini PC for $130.
Yes, the same. And this is the diagram I already showed in a video about work processes. Let's try to locate the ICM.
I see this on the primary application server. So this is part of application instance.
Yes, it is. In my case, this is the instance 00. Let's confirm this in the system. I'm logged as A4HADM user. I can use the well-known SAP control command to see what components are running. ICM is the last one. Its process number is 4244. I can use PS command to check this process. Indeed, this is ICM, which belongs to SAP system A4H and instance 00. Here are details. icmon is the real program. It is part of SAP kernel.
Do I understand correctly that ICM is a separate component, but also an interface between the SAP ABAP system and the Internet?
Yes, you could say that. Besides, it's not only between ABAP and the Internet. Java systems can also use ICM. Moreover, if you are familiar with Web Dispatcher, it is actually very similar to ICM, with which it shares much of its code. However, let's focus on ICM working with ABAP for now. Here you have a more detailed architecture of ICM.
Wow, that whole blue rectangle is ICM? It looks like a system in miniature by itself, yet you showed that it is just one process.
Yes, indeed. When you look at ICM, its architecture may bring to mind the episode in which I described work processes and ABAP dispatcher. ICM has thread control, which accepts connections and distributes them between worker threads, somewhat similar to dispatcher. Although here we have a separate watchdog to keep an eye on workers and a signal handler to process operating system signals. In addition, there is also a table with a list of connections, because not all of them have to be assigned to a worker. It is a bit like a dispatcher queue. Besides, we have Internet Server Cache for speeding up repetitive HTTP requests.
How is it possible that all this is handled by one process?
The implementation was done on the basis of threads, not processes. But we'll get to that in a moment in the practical part. Let's look at communication for a moment more. Since the ICM is on each server, memory pipes have been chosen for data transfer. This is an efficient way to do it, because there is no need to copy them, but only to send pointers. Besides, the dispatcher and ICM also communicate directly when needed. For example, when ABAP wants to initiate a connection to the outside, or when the worker thread has to put a task in the dispatcher's queue. It is perhaps worth mentioning at the end that worker threads can support different protocols, thanks to a mechanism of dedicated plugins.
We have already discussed the entire diagram. Can we see it in practice?
Of course, as always. We have 3 ways to manage ICM, but it's probably a good idea to start with the simplest one. That's why I logged into my system. The right transaction is SMICM. This is a transaction for monitoring the component. At the top, we have information about the current status of ICM. Green is good. The table at the bottom is a list of worker threads. In the middle, we have a summary of workers, connections, and queue. As you can see, we currently have 10 workers with a maximum of 500.
Pretty clear.
Let's go back to the operating system for a moment. We remember that the process ID of our ICM is 4244. This is the process. Now let's add the -T option to the PS command. This allows you to see the threads inside the process. Yes, it's true that ICM runs on a single process, and all parallel processing is realized using threads. In the list there are not only workers, but also helper threads like watchdog, signal handler, or main controller.
Okay, what can we see as next?
Let's see the ICM trace, where we can find information on startup process. This is the log created at the start of ICM. In the operating system, you will find it in the work directory of the instance. At the top, we have information about the file and the system: instance number, system ID, architecture, version and patch number, active instance profile, and process ID. ICM read from the profile that it was dealing with an ABAP system, and a moment later attached the system. Later, the name of the security log is mentioned, and the host on which ICM is running. Port 64999 is listed as administrative. Then there is whole section related to attaching shared memory segments. Next, we have information about memory pipes. You probably remember them from the architecture diagram. It is through them that ICM communicates with work processes. You can see exactly that it is only at this point that the worker threads are brought to life. There are 10 of them, and moments later 2 watchdog threads start. A moment later, we have information about the cache on disk and in memory, and then the registration of the administrative interface handler. It will only work on port 50,000. I'll tell about it later. Later, we have a whole section of port entries. Here is information about WebSocket and LDAP plugins. Next, you can see the start of the HTTP service on port 50,000. You can also find information about HTTPS on 50,001. Then you have SMTP, so Email Exchange Protocol, on port 0. Port 0 doesn't exist and is a kind of fake port, but I'll tell about this later. Then I see HTTP on 80. Finally, you can see that the network services were initiated without any problems. Here's a whole section on SSL initialization, related to encryption and required for HTTPS, among other things. At the very end, you can find information that ICM has started correctly.
Quite a lot of information can be read from this file.
Yes, indeed, and this is just information about the start of the service. If there are problems, we look for error information in this file.
Well, we are back by the threads. You mentioned that threads are not the same as connections. Where can you see the difference?
That's right. On the diagram, we saw worker threads, and separately a table with a list of connections. What we see when we enter the SMICM is a list of worker threads, but we can also check the connection list. From menu Go To, I choose Connections and then Display Connections. As you can see, the list is currently empty. Let me open my web browser. Now I will initiate connection to my SAP server. I will use SAP BC Ping service, which requires logon. Of course, it's an HTTP connection, so it will go through ICM. Server reached. I switch to SMICM, to the list of connections, and click Refresh. The connection appeared in the list. There is information about the protocol, the client's address and its port, and that it is HTTP keep alive. What does that mean? After all, the connection has actually ended, but not quite. Web browsers, after loading a page, by default leave the connection to the server open, because there is a probability that further requests will be needed. And since it always takes a long time to initialize the connection, so the connection is kept open. When I go back to the list of workers, on the other hand, I see that none of them are taking care of this connection. That's not surprising, because there's not much to do with a connection that is only artificially sustained. However, you can see that the two lists are not the same. It's a bit like logged-in users and dialog processes. A user doesn't consume a process when it's not doing anything. In the same way, a connection doesn't use a worker when it's not needed. I will still show you that the browser actually keeps this connection. I confirm that the connection is still active. On the other hand, when I close the browser, the connection should be terminated. As you can see, consequently it also disappeared from the list.
Okay, I already know more and more about how ICM works, but how do you configure it?
Since ICM is part of an SAP instance, so it is natural that the configuration parameters should be in the profile of the instance to which ICM belongs. However, by selecting Go To, Parameters, Display from the menu, we can view the most important parameters, keeping in mind that this is only a small fraction of them. At the beginning, we have a group of parameters related to running services. I will talk about them in a moment. Next, we have the definition of limits, because every server must have defined limits. Next, we have parameters related to the number of worker threads. This is why 10 threads are created at the beginning. And, as we saw earlier, the maximum number of threads is 500. Lower down is the group defining log files and statistics collection. Later, CCMS-based monitoring. Certainly an important group is timeouts. In my experience, the idea of changing these parameters comes up whenever there are problems with responses to clients. This is not always a good idea. Reverse invoke is related to working with Web Dispatcher, which is a type of reverse proxy for ICM. Further, various parameters related to the operation of HTTP, which is an important application of ICM. Later, error handling and a larger group related to SSL. If you are interested in encryption and security, there are more videos on these topics on my channel. Finally, we have context quotas definition, memory pipe settings, content filtering, and some parameters that don't fit into other categories.
Quite a few of the parameters. If these are only basic, I noticed the ones related to services. I guess that's important.
Yes, I would say that services are one of the most important things in ICM. That's why we have a dedicated option in the Go To menu. Here we have a list of working services. HTTP on port 50,000. I have already connected to this port by calling ping in the browser. HTTPS on port 50,001. Then we have an interesting thing. SMIP on port 0. As I mentioned earlier, port 0 does not exist. However, this means that the service is running, but is not listening on any port. Thus, even if you can't connect from the outside, SAP can use SMTP when communicating with the world. I will demonstrate this a little later. Finally, we still have HTTP port 80. It is worth knowing that SAP to open ports below 1024 needs a special kernel component. But we'll talk about ICM bind later, or in an episode about the kernel. In summary, I expect that 3 of these ports are opened by ICM. I will confirm this at the operating system level. I will use the ss command to check the port. If you don't know it, I recommend a video about useful Linux commands. The L option comes from listen, while P will show us what process opened the connection. I check port 50,000. As you can see, the port is open. In the last column, we can check that the owner is ICM with process ID 4244. Let's see what other ports are opened by this process. All as I expected. There are 3 ports which we know. In addition, we have 64999, which we saw in the log earlier. But this listens on local loopback only, so it isn't accessible from outside.
How can we further confirm this?
If you are not yet convinced, let's do an experiment. I'll deactivate port 80 for a while and see what happens. Here is the option to deactivate the port. The line is marked with yellow and the green mark was removed. Let's repeat the last OS command.
Okay, I see that the port 80 is no longer on the list, so it stopped listening.
Yes, indeed, it was deactivated. But I can show you even more interesting operation. There is an option to create a new service. I choose port 50,002. I don't want to bind to an interface. I can choose a protocol from the long list of internet protocols. Let's use HTTP again. ACL file is for access control, then a few other options. I see that this is temporary service until restart. This is clear. To keep the service permanent, I need to add this using profile parameters. Now I can check what we see on OS level. 50,002 is listening as expected. I can confirm that if hasn't been written to profiles. Empty result. In contrast to 50,000s is defined in profile. Let's now restart ICM and the port should disappear. To restart, I need to go to the main screen of SMICM and choose Administration. ICM Exit. Soft is Graceful Restart. I have to confirm that I know what I'm doing. ICM has been restarted. Now we can check if the temporary services are still visible.
Yes, they are. Why?
I just need to refresh because it is an old view.
You are right. They disappeared now.
Yes, of course. We can confirm this on OS level. I need to check what is the new process ID of ICM because I restarted it. I use SAP control command as always. The PID is 4726. Now I can use SS command to check ports. Oops, a little typo. Missing pipe. The set of ports is known and expected.
One thing I'm curious about. To restart ICM, you chose exit, not restart. How did you get the ICM working again?
Yes, the exit soft function sends a signal to or SIGINT and allows you to terminate connections. If I had chosen exit hard, it would have sent a signal 9 or SIGKILL. I could achieve exactly the same thing using the kill command in the operating system. However, it is clear that each of these actions terminates the process, not restarts it. Instead, the watchdog function here is performed by the ABAP dispatcher. Just as it restarts work processes when they stop running, it restarts ICM when it disappears. You don't even have to take my word for it. I'll show it to you in the dispatcher log. Just as earlier the dispatcher started the ICM when it got PID 4244, later the dispatcher noticed that the ICM was gone and restarted it. This time the operating system assigned it a process ID of 4726, which it still has, by the way. This can be confirmed by checking the processes of our instance. You see 4726 and the same 4726.
Okay, pretty clear. And if you had to point out one thing from ICM that is used most often by an administrator in day-to-day work, what would it be?
Well, every system is unique and these can be different things. But in many systems, especially where Fiori is used, HTTP has become the leading protocol, or more often HTTPS. The administrator frequently looks at the logs to see what URLs users have called.
Where can I find these logs?
Well, first you need to define it. I can show you my system settings. ICM HTTP logging and number of port definition is the parameter which defines logging. Log file value defined pattern of the file name. Port definition number corresponds to ICM server port parameter. In my case, port 0 is HTTP on port 50,000, where port 1 is HTTPS on port 50,001. I will move to the browser for a moment to invoke SAP BC ping over HTTPS. We'll see later if the corresponding entry appears in the defined log. Okay, the server responded. I can now return to OS to see the right log file. By default, logs are located in work directory of the instance, where ICM belongs to. In my case, this is A4H system and instance 00. Log file parameter points to access underscore https underscore log underscore date. This is the first file. The second line is my request to SAP BC ping. My source IP is visible, then my username because I logged in, date and time, then my request. Finally, HTTP return code 200, which means OK and the content length of only 41 bytes.
Why exactly 41?
This is the size of the document returned by the server. The server reached text is shorter, but when I look at the HTML code of the page, I see that the whole thing with tags is 41 bytes.
I understand. This log is probably very helpful, but I bet it doesn't contain all the connection information we can get, right?
Yes, you are right. We can find out more, but at the moment HTTP trace info is disabled. I need to activate this first to save the data to the ICM trace. I choose Go to, Trace Level, Activate HTTP Trace Info. No, the HTTP trace is active. I return to the browser and reload the ping page to make another call. On the OS level, I'm still in the work directory, but this time I'm interested in dev_ICM file, which is the trace. Yes, this is my request information. This is HTTP request, method is GET, and URL is SAP/BC/ping, called host and port information appers. Then I see all the headers sent by browser, user agent, acceptable document types, languages, encodings, cookies, authorization data, and all other details which are sometimes needed by a developer or an administrator.
Quite a lot of data.
Yes, that's why you should always remember to turn off HTTP trace as soon as you no longer need it.
Yes, I know that excessive logging is a problem for many systems, and it takes up space. And can you tell me what other options I have in SMICM?
Sure. Why don't we just go through the entire menu? The trace file option allows you to view, save, and reset traces. We have used this before. Trace level sets the detail of the logging. You can view or change profile parameters. Various statistics help to track performance. Here's an example, although there's not much going on in this system. As we already know, memory pipes are used to exchange information with dispatcher and work processes. Here you can find out more about them. Next, we have a hostname buffer. It helps speed up frequent connections to the same hosts and reduce the number of queries to DNS. In rare cases, when a name is resolved incorrectly, the buffer may need to be reset. Then we have services, which we've already discussed in details. The same for connections. Release notes is an information about version. Then we have HTTP-related submenu. Here, for example, we can view the logs we have already seen at the operating system level. This is my HTTP log. It looks familiar, doesn't it? Then we have an administration menu. Two options to restart ICM, which we've already discussed. Then maintenance mode, which I'm activating right now. I'm confirming. As you can see, status has been changed to maintenance marked as yellow. Now, when anyone tries to access the system via ICM, they are told that the system is unavailable. Also, the 503 response code indicates that the service is unavailable. When I turn off maintenance, everything goes back to normal and the server responds perfectly. There are two more moderately useful options in the menu. The first allows you to reload the configuration without restarting. The second one sets the ICM startup parameters. As you can see, however, there are not many of them. Trace file name and default login level. Nothing special.
One thing still makes me curious. At the beginning, you mentioned that ICM can act as a client and a server. Can we see this somewhere?
I will demonstrate maybe ICM in the role of a client based on a quite popular problem. I mentioned that to act as a client, ICM needs a running service, even if only on a non-existent port 0. I will show that this is indeed the case. I'm deactivating both HTTP services. They are marked as non-active. Now I can go to SM59 to see if there are any RFC which use HTTP. I'm checking HTTP connection to external server. There are 3 default connections. Let's check the first one. I see that the port is 80, so this is HTTP. This can be confirmed by an inactive SSL option. By the way, if it were HTTPS, I could choose here the PSE container that the client uses to establish the connection, depending on whether you want SAP server to authenticate or act anonymously. However, I am now interested in HTTP and connection test. The connection was not possible and I received this error. Probably worth checking the details in Trace ICM. I'm returning to SMICM to choose option to display the ICM trace file. Here it is. This is my trace. I'm scrolling down to find the error. This is marked in red. No service for protocol HTTP was started. So the connection was not possible because I deactivated HTTP service. It's war to remember about this fact. It may happen that you want to deactivate the service on the server for a while, but you must then remember that connections in the other direction may also not be possible.
In the episode about Dispatcher, you showed that we can monitor it without logging into SAP using icmon. Do we have something similar here too?
Even more. We have two tools. But I'll start with icmon, which has a similar interface to icmon. The principle of operation is similar, so I also need an instance profile. I am immediately shown a list of workers. I can see their status. I can also see the other threads we saw when we discussed the architecture. In the icmon menu, of course, I have many more options. For example, I can check the use of memory pipes. But this time, I'm interested in authentication. At this point, it is worth mentioning that ICM does not connect to the database. As we recall the diagram with architecture and connections, we can see that the database does not appear here. Quite a logical move, since ICM in a sense is supposed to isolate the SAP system from the outside world. However, it does have consequences. There is no way to store user information in a database. That's probably why the developers used a dedicated ICM auth.txt file. Similar, by the way, to the web dispatcher, with which ICM has a lot in common. I listed users defined in the file. There is only one user, web admin. Secret password hash is visible, but this is a temporary password only. I would like to reset this password. I'm asked about a new password. I need to repeat this, and additionally save changes to the auth file. Now I can show you the second tool, but first I'll show you how it is defined in the instance profile. ICM HTTP admin 0 defines access to an admin interface. Prefix URL helps to find the interface. Auth file specifies where the passwords are stored. Port limits access to only certain port. It is useful when you want to open this port on firewall to a secure network only. In my browser, I'm opening webadmin URL. Obviously, I need to use port 50001 and HTTPS. Prefix URL is SAP/admin. I need to authenticate with webadmin user and password. Finally, I'm logged into the ICM admin web interface. The options are very similar to those found in the SMICM transaction. We have a list of workers and statuses, just like the main SMICM screen. Active services with the same handling options. Other ICM threads, active connections, plus a list of the most active clients, trace file, parameters, hostname buffer, release information, statistics, memory pipe summary, ICM security log, then HTTP specific entries, known access log, both settings and the contents, cache information, plus handler's settings. We can assume that this mirrors SMICM transaction.
Wow, there are actually quite a few possibilities to operate ICM. I think I learned pretty much everything today. A solid dose of information.
Yes, it's certainly not everything, but you always have to start somewhere.
Thanks for this presentation. I'm going to give a thumbs up to this video because it supposedly helps a lot in the development of the channel, as do the comments from viewers. I have already subscribed to the channel, of course.
Thank you, I appreciate it, and I hope all viewers will do as you do. May your packets passing through the internet always form a stream hitting the right ICM. Until next time.
See you soon, I hope.